Okay, here see I am going to present two classes on electrochemical cells. Now electrochemicals are mainly two different types. One is a galvanic cell and the other is an electrolytic cell. What is a galvanic cell? A galvanic cell is one in which the chemical energy is converted to electrical energy and we can use them as source of electric current. And in electrolytic cells, the electrical energy is converted to chemical energy and we can carry out non-spontaneous chemical reactions using electric current. So, mainly there are two different types of electrochemical cells, galvanic cells and electrolytic cells. We have already completed the other type of the reactions taking place in galvanic cells, etc. all. Now we will come to the main class of electrochemistry, part of electrochemistry, the batteries. Now what are batteries? Batteries are actually the galvanic cells in which the chemical energy is converted to electrical energy. The galvanic cell, the chemical energy stored in chemicals is converted to electrical energy. Now batteries again, the main qualities of a good battery is the battery should be easy, very composite to carry, very easy to carry them. Then the voltage must almost remain a constant. It should not be large variation in the voltage during the chemical reaction taking place. Okay. Now there are mainly two different types of batteries, primary batteries and secondary batteries. Now so batteries are galvanic cells. Batteries are galvanic cells where the chemical energy is converted to electrical energy. And we can classify battery into mainly two types. They are primary batteries and secondary batteries. Primary and secondary. Primary batteries and secondary batteries. Now, primary batteries we can, once the chemical reaction is over, we will have to just throw it because we cannot recharge them or reuse them. Once the chemical reactions are over, the battery is dead. We cannot reuse them. We cannot recharge them. We cannot reverse the reactions. That is the problem in primary cells. Once all the reactions are over, it should be thrown. It should be destroyed. Understood? So that is a primary cell. Whereas in secondary cells, they can be recharged again. Once the reactions are over, you do the backward reaction using electric current. Again we can store energy there and again the chemical reactions can take place to give the electrical energy. So that is a secondary cell. They can be reused after recharging. So the mainly two classes, primary and secondary. Now in primary, the main type of primary cell is a dry cell. Even in 17th century onwards, this dry cell they are using. See, that is the Leclanche. He first made the dry cell, that is zinc carbon cell. They are called zinc carbon cells. So that is why it is called a Leclanche cell. Dry cell is called a Leclanche cell. So this is the transitionally cut portion of a dry cell. So here you see dry cell consists of any cell must have an anode, a cathode and electrolyte must be there. And you must know what is the reaction taking place at the anode, reaction taking place at the cathode and the overall reaction. So this is a dry cell. You see the dry cell here, it is containing a zinc plate, zinc can. All the chemicals are filled in the zinc can. The zinc can itself is working as the anode. So the zinc is acting as the anode here. And at the anode we know in an electrochemical cell what is happening at the anode? Oxidation is taking place at the anode. So zinc will be oxidized to zinc ion at the anode. Okay. Now the cathode. What is the cathode? Cathode is this graphite rod. Graphite rod with a metal clip. You can see the metal clip here. with a metal clip is acting as the cathode, and surrounding this graphite rod there is a paste of manganese dioxide and carbon. So manganese dioxide and carbon is mixed, that is why black in color. It is covered, the graphite rod is covered with mixture of manganese dioxide and carbon. Now what is the electrolyte? Electrolyte is a moist mixture of ammonium chloride and zinc chloride. So the electrolyte is a moist mixture of ammonium chloride and zinc chloride, all will be filled here, and at the anode what is happening? Oxidation. The zinc will be oxidized to zinc ions. And what about the cathode? Cathode reaction. Cathode, the manganese dioxide is reduced to Mn2O3. That is, from plus 4 oxidation state, it is reduced to plus 3 oxidation state. And a voltage of 1.5 volts is maximum voltage obtained from a dry cell is 1.5 volts. So this is a dry cell. Now, so dry cell is the main important type of primary cell. And you might have seen dry cell in lot of the torches, clocks, etc. We use this type of dry cell. Now next type of cell is a mercuric cell. Mercury cell, you see, it is very small. Mercury cell, very composite, very easy to use, isn't it? So this is used, this is actually mercury cell is used in watches, hearing aids, etc. Now there, the anode, again there is an anode, zinc amalgam. What is an amalgam? A mixture of mercury and zinc. That is called an amalgam. Zinc amalgam is used as the anode. And what is the cathode? Cathode contains mercuric oxide. Cathode contains a paste of mercuric oxide and carbon. So at the anode, oxidation will take place. Zinc will be oxidized to zinc oxide, and at the cathode, mercuric oxide is reduced to mercury. This is what is happening at the cathode and anode. And one advantage of this mercury cell is the voltage remains a constant throughout its life. Since the voltage is remaining constant throughout its life, it is used in hearing aids. Understood? So these are the two different types of primary cells. A dry cell. A dry cell is a type of electrical battery commonly used for portable electrical devices. It was developed in 1886 by the German scientist Carl Gessner after the development of wet zinc carbon batteries by Leclanché in 1866. The modern version was developed by a Japanese scientist in 1887. A dry cell uses a paste electrolyte with only enough moisture to allow the current to flow. A common dry cell is the zinc carbon cell, sometimes called dry Leclanché cell, with a nominal voltage of 1.5 volts. It is, so this cell, that is cell is called a Leclanché cell. Now what is anode? The anode is the zinc metal can, and the cathode is the manganese dioxide and carbon paste. The electrolyte is a mixture of ammonium chloride and zinc chloride, a moist mixture actually. Moist it must be because the electrons can have to flow. Cell potential 1.5 volts, but even decreases up to 0.8 volts. Now what is the anode reaction? The anode reaction is zinc is oxidized to zinc 2 plus ion. So zinc is oxidized to zinc 2 plus. At the anode always oxidation will take place. Now the cathode. What is happening at the cathode? Reduction. 2 NH4 plus aqueous plus 2 MnO2 solid plus 2 electrons. Addition of electron, that is reduction. Mn2O3 solid plus 2 NH3 plus 2 H2. Now what is the overall reaction? Zinc solid plus 2 NH4 plus aqueous plus 2 MnO2 solid gives zinc 2 plus aqueous plus NH3 aqueous plus H2O plus Mn2O3. Now the ammonia gas formed here, ammonia molecules which is aqueous, that is reacting with the zinc to form a zinc ammonium complex. So after some time in this moisture formed, this it will dissolve, the complex will dissolve, and you know that the dry cell batteries, they leak out. And you see the figure of dry cell. The figure of dry cell you can see, it is the outer covering of paper, and inside we have the zinc anode, the metal cap there, below that the carbon rod, that is the graphite rod, which is the cathode, and around the cathode you can see the paste of manganese dioxide and carbon, and after that a moist paste of zinc chloride and ammonium chloride. Okay. Now the next type of mercury cell is, primary cell is mercury cell. A mercury cell, it is called also a button cell, is a non-rechargeable electrochemical battery, a primary cell. Mercury batteries use a reaction between mercuric oxide and zinc electrodes in an alkaline electrolyte. The voltage during discharge remains practically constant at 1.35 volts, and the capacity is much greater than that of a similarly sized zinc carbon battery. The mercury batteries are used in the button cells for watches, hearing aids, cameras, then calculators, etc. Now, the reaction taking place in a mercury cell. The anode reaction, you see zinc amalgam, zinc is oxidized to zinc oxide. The oxidation state of zinc in zinc amalgam is 0. In the product side zinc oxide, the oxidation state is +2. That means zinc is oxidized to zinc 2+. Then at the cathode what is happening, you see mercuric oxide, where the oxidation state of mercury is Hg2+. It is reduced to Hg, that is with oxidation state 0. So mercuric oxide is reduced to mercury. That is happening at the cathode. And the overall reaction you can see, it is zinc amalgam, that is zinc Hg. Amalgam plus HgO gives zinc oxide plus Hg. No ions are taking part. See, no ions are taking part in the reaction. That is why the voltage is remain a constant throughout its life period. The EMF or voltage is remaining a constant. And you can see the figure of a mercury cell. In the mercury cell you have a cathode. You can see the cathode, a steel cap is there. Below that there will be zinc. Then at the cathode you can see a steel cap. Below that there will be mercuric oxide paste. Then anode you can see the zinc can, and the electrolyte is a potassium hydroxide, containing potassium hydroxide and a paste of zinc hydroxide and mercuric oxide, that is the electrolyte, alkaline. Since potassium hydroxide is there, the electrolyte is alkaline in nature. Okay, so these are the reactions taking place at the mercury cell, and it gives a constant voltage. Since the constant voltage is there, it is usually used in hearing aids. In hearing aids, mainly it is used only because of its constant voltage. We have seen two different types of primary batteries, that is a dry cell and a button cell or mercury cell. The dry cell is used in torches, clocks, etc., which is where the zinc is the anode and graphite is used as the cathode. You know that it does not give any constant voltage from 1.5 to 0.8. From when it's starting we will have 1.5 volt we will get, but when the last end we will get only 0.8 voltage, 4.8 volt. So that it's not giving any constant voltage, and it is not that composite to use. But mercury cell is not like that. There the anode is zinc amalgam and the cathode is mercuric oxide paste. Zinc is oxidized to zinc oxide and mercuric oxide is reduced to mercury, and in the overall reaction no ions are taking part, so it gives a constant voltage. That is the main advantage of mercury cell.